Assalamualaikum and hello everyone. My name is Lia Maisara binti Abdul Razak with metric number AE2039 and I will explain for the circuit analysis by using the Fourier series. So basically this is our group circuit which have a 2 resistor, 3 capacitor and 2 inductor that connect to the power supply. So this is the waveform of our graph where we get the square wave graph where the VST from 0 to 1 we got 10 and where T from 1 to 2 we got 0. So basically the period of the graph is 2 seconds, the amplitude of the graph is 10 and lastly the fundamental frequency by using omega is equal to 2 pi over T and then we substitute the value of T with 2 and the omega is pi. After that, by using the general equation of the Fourier series, VST is equal to A naught plus summation where n is equal to 1 an cos n omega t plus bn sin n omega t. And we use the equation a naught equal to 1 over t integrate from 0 to t vst dt equal to, we substitute with the t value with 2 and integrate from 0 to 1 10 dt plus integrate from 1 to 2 0 dt and we got the a naught is 5 and then we use the formula of an equal to 2 over t integrate from 0 to t vs t cos n omega t dt and then we substitute the value of t with 2 and we integrate, we got value of an is 0 and lastly for the bn we use the formula of 2 over t integrate from 0 to t vs t sin n omega t dt and we substitute the value of t with 2 and after that we got the answer is negative 10 over n pi cos n pi minus 1. We know that in the slide given that they said that cos n pi is equal to negative 1 to the power of n. After that we substitute the value of cos n pi with negative 1 to the power of n and then we rearrange the equation and we get 10 over n pi times 1 minus negative 1 to the power of 1, to the power of n. And then after that, we substitute the value of n with odd number such as 1, 3 and 5 and some more, we got 20 over n pi. And we know that if we substitute the value of n with the even numbers such as 2, 4 and 6, in this equation we got 0. So we know that from this equation VST is equal to 5 plus 20 over pi sin pi t plus 20 over 3 pi sin 3 pi t plus 20 over 5 pi sin 5 pi t and more.
So next, after we got the VST, then we need to find the reactance of the impedance in the circuit. So for inductive reactance, it is an XL. It is written as SL. Then for capacitive reactance, which is XC, XC is written as 1 over SC. Then we need to find Z, which is the XL plus XC is parallel with R plus XL plus XC. So for XL plus XC, it is S square plus 10 to the power of 9 over 1000 S. And for R plus XL plus XC is equals to 10 S 10 mega plus S square plus 10 to the power of 9 over 1000 S. Then we can find the Z. So to find the Z, we need to insert all the information obtained to get the Z. So this is the answer for Z. Next, we need to find the Z total. So for Z total, it is an Z plus 10K plus 1 over 1 micro S. So this is the answer for Z total.
Hello, my name is Ma'aris Noashidi bin Manazir. My number matrix is AE200016 and I will explain for the manual calculation. Then we can find for V0, which is V0 equal to VRLC equal to VRC. equal to Z over Z total times with voltage source. So this is the calculations that we have done. So okay, for V naughts, we find for when n equal to 1, and we get the answer here. After that, we proceed to find when n equal to 3. We also find the n when equal to 5. After we get the V naughts, we can now proceed to find I1 and I2. So if you can see from the circuit givens, and this is I1 and this is I2. So we're gonna find the current for I1 and I2. After that, we can find for I source. For I1 and I2, we do the same step. We find when n equal to 1 for I1, and also the same for I2. Then we find when n equal to 3, n equal to 5. After we get the answer, then we can find for I source as well. So for I source, Is equal to Vs1 divided by resistance plus capacitance. So we find for N1, N3, and N5. After we got the answer, we list down all the answer here. You can see this is for Vs, V0, I source, I0 is equal to I1, and then I2. So after that, we will continue for voltage amplitude and phase spectra. So first we list down the V0 for 1, 3, and 5, and then you can see this is the amplitudes, and this is the phase spectra for voltage. Same for currents. This is the voltage amplitude, and this is the phase spectra. So I think that's all from me. Thank you.
Greetings to Doctor. My name is Nur Natasha Amira binti Mak Nasir, and my metric number is AE2041. Now, I will make an explanation for the manual calculation for power in any branch. So, for the power calculation, I will choose this branch, which is the first branch, which is the value of resistor R1 is 10 kilo ohm, and the value of capacitor C1 is 1 microfarad. So the formula for power is P equal to V times I, which is voltage times with current. So if I choose the first branch just now, so we need to calculate for V01 times with I01. So the value for V01 is this value we obtained before. V01 equal to 1.91 with an angle of negative 90 degree volt, and while the value for I01 is this value, I01 equal to 6 micro with an angle of negative 0.57 micro degree ampere. So we insert these two values all together, we times it all together, and we will obtain the value for power is 1.14 milli with an angle of negative 180 degree watt. That's all from me. Thank you.
So next, this is the simulation for our circuit, and this is our circuit. So first we look at the I1. This is the waveform obtained for I1, and the value is quite different from the manual calculation. Next is we look to V1. This is the waveform obtained for V1. The value is almost the same with the manual calculation. Next we look to I2. This is the waveform obtained for I2. The value is also quite different with the manual calculation. Next we look to V2. for V2, the value is quite similar with the manual calculation. Next, we look to I3. For I3, this is the waveform obtained, and the value is quite different with the manual calculation. And next is V3. For V3, this is the waveform obtained. The value is almost the same with the manual calculation. And lastly, the power. So this is the waveform obtained for the power, and the value is almost the same with the manual calculation. Thank you.